What up, Taylor Tots? As you can tell, today we are going to be looking at some balancing chemical equations. I got 6 on the board, and we're going to do a 7th after we're done with these. Again, the point of this video is just to give you some more practice with it. I'm not worrying about word problems right now. I don't know right now 100% if I'm going to be able to get a naming video up this weekend, but I will probably have a naming one up soon. But again, my goal is to keep this under 15 minutes for this video. We're going to get through these reactions, and I'm going to kind of just walk you through them again as well. I'm probably going to just zoom in on the first 3, and then I'll zoom down, so I will go back with the camera just to let you know, just to make it a little bit bigger for everybody. Awesome. And again, from my angle, that looks good. I'm hoping it works out for you guys as well. What you'll notice immediately is that even if some of this stuff looks really big and scary to balance, it's not really all going to be that bad. For instance, the first rule that we always talk about is, again, and we talked about this through the notes, is again, what's going to be big, what's going to be obnoxious for you to balance. Looking at this, I think we have a few options for what's challenging. I also noticed right away that that's sulfate and that's sulfate, so that might make our job a little bit easier. There's only one of them on each time. Looking at this, I'm just going to put a 1 here. Potassium sulfate. Well, potassium sulfate will react with barium chloride to produce potassium chloride and barium sulfate. Looking here, I have 2 potassiums. Again, 1 times 2 is 2. I only have 1 over here right now. Because of that, I need, through the distributive property, 2 KCl's. Again, what this actually does is this kind of simulates, hey, we have a second KCl. And now I have 2 KC and I have 2 CLs, which is actually pretty cool. And speaking of CLs, because I now have 2 of them, again, 2 times the 1 is 2, how many do I have over here? Yep, 2. Again, if we already have 2, we're good to go. I have 1 barium here. Dang, I got 1 barium here. That's good. And then we pause. It might look like we're done, but again, just to be smart with it, we have to double check sulfate. We haven't talked about sulfate yet. Again, I have 1 whole sulfate, and over here I have 1 whole sulfate as well. So when you're balancing, this kind of process works every time. Again, find what's scary, put a 1, and start there. Again, you don't want more of this stuff. The numbers get really big. And again, me saying that this is just sulfate makes our job actually a lot easier. Again, please, please, please do oxygen last. The reason being, oxygen can appear a lot of places. Even though you can't see the other ones right now, we have 6 problems. Only 1 of them doesn't have oxygen. And it's honestly that common. Because it's that common, it's hard to juggle where they are. And if it's hard for you to juggle where they are, you're going to be doing more math, you're going to be working with more numbers, there's more of a chance you're going to make a mistake. And again, we don't want you making any mistakes. Here, combustion reaction. Again, this is a double replacement reaction. This is a combustion. I'm guessing everyone's going to say that the fuel, the hydrocarbon, is going to be what's strong. Again, with this one, this is where you have to watch out for the odd-even rule. Again, you don't know by looking at it if it's going to work or not. But again, just in case, you might need to multiply. You know what, I'm just going to write out everything because I have a little more space I didn't on the smartboard during notes. And you'll be good to go. I have 5 carbons here. I only have 1 here right now. So, again, I need to get that to a 5, so that's going to be a 5. Again, oxygen's last. Again, 1, 2, 3. I'm not juggling all that yet. I got 12 hydrogens. All right, I need 12 hydrogens. Well, 12 times 6 is 12. Oh, sorry, 6 times 2 is 12. Well, looking at it here, this is where you might need it. Let's see. I have 10 oxygens here. I have 6 here. That's a total of 16. And because of that, how can I turn a 16? Can I get a 2 to be a 16? Well, actually, in this case, I can. All we need is an 8. So, actually, that one we don't have to do it. We lucked out a little bit. The 7th problem, we'll definitely do this for sure. But again, I just wanted to bring it up. Going through this one, again, a double replacement. Looking at this one, I think everything is pretty big. I think you'd be fine. Kind of first looking at, okay, are there polyatomic ions? Yes, there are. I got ammonium, I got hydroxide twice. I'd say one of these two might be the challenging thing. Looking at it, you know, I'm just going to pick this one because I see the 2. Again, we'll see how that kind of goes. Again, calcium hydroxide is going to react with ammonium chloride to make ammonium hydroxide and calcium chloride. So again, looking at this, what I'm going to do is I'm immediately going to see how many calciums I have. I have 1. How many do I have way over here? Well, I have 1 as well. Again, I'm just adjusting the camera a little bit. I apologize. So I'm going to put a 1 here because I'm good. How many chlorines do I have? Well, I have 2. Well, here I only have 1. Well, how do I get that 1 to be a 2? You put a 2. And looking at this again, how many ammoniums? Again, if you want to look at just nitrogen and just nitrogen, go ahead. If you want to look at just hydrogen, go ahead. The only issue with that is, if you look, hydrogen's in 4 places, and 2 of them are over here. So it is a little more challenging. I would say just keep ammonium together. Why not worry about 2 things when you can worry about 1? I have 2 ammoniums here because there's only 1 ammonium, which means I need a 2 here. Now, I have 2 of these guys. And to follow along with that, I have 2 hydroxides now, because this whole thing distributes over. Well, I have 2 hydroxides. I'm actually good to go, which is kind of a really cool thing. As big and scary as this one might look, there's a lot going on. There's a lot of H's. There's some polyatomics. It's actually not too hard. Some of you probably could solve this in less than 5 seconds. I'm going to go back. I'm going to adjust so you can see the lower 3 right now as well. And right now I am on pace to keep this video lower, which is kind of a nice thing as well. Thumbs up, bro. Looking through these, again, just really quickly looking at the types of reactions. I have a single replacement. I have another single replacement. And I have another single replacement. Again, I'm not really doing synthesis and decomposition. Again, those are smaller ones. I kind of want you to see some bigger ones right now. Just looking through this one, this vanadium 5 oxide plus calcium is calcium oxide of vanadium. I'm immediately putting a 1 here. I think it's pretty obvious that's the biggest thing. Looking at this as well, I have 2 vanadiums. So let's put a 2 right there. I have 5 oxygens. I have 1 oxygen. Again, and you know what? Oxygens should be done last. So you know what? Even though that one isn't too bad, as you can probably see, we're just going to go immediately to the calciums. Because again, this might show you a little bit of a doubling back. Calcium, again, is 1. There's only 1 here, so that's 1. But again, what you notice from this, I have 5 oxides here. 5 oxygens. I only have 1 here right now, which means I would have to double back. I get a 5 here. And again, if I'm putting a 5 there for calcium, I'm immediately having to change that to a 5. So 1, 5, 5, 2 is balanced there. Yes, if I jumped the oxygens, I would solve this a lot quicker. But, you know, just a good habit to just do oxygen last. You never know where it can be sneaky. Trust me, you want to make sure you're doing that last as much as you possibly can. This one, also just to let you know, calcium is more reactive than vanadium. This reaction would work. Vanadium's kind of in the middle of the cheat sheet. It's not actually on it, but this one definitely would work. Calcium is better in terms of a metal. It's more reactive than vanadium. So this would happen. Honestly, same kind of thing on these two as well. This time, again, we kind of had some metals that we were looking to switch, which is the top of that cheat sheet I gave you. Here, though, at the bottom, we have two examples where actually we're kind of doing the non-metals in all honesty, which is that bottom part, which we haven't touched on really too much. Again, fluorine is the king. Fluorine will displace everything. Very powerful, very small because of it. Again, that electronegativity piece comes in. So this is better. This one is better. So these reactions would, in fact, happen. And again, that's something worth talking about. Because again, if this isn't going to react, why would you even try to balance it? Again, I might try to trick you on the quiz, and say, hey, balance this, and you actually don't even have to. So again, keep that in mind. Just to finish the last two up, again, looking at this, I think the big thing is either going to be cobalt 3 chloride or cobalt 3 fluoride. In all honesty, I'm just going to put a 1 here. The cobalt 1 chloride. I got 1 cobalt. I got 1 cobalt. Let's check that out. Well, I got 3 fluorines. I got 2 fluorines. Again, I got the 3. I got 2. This is actually an example of the odd-even rule. There's no way to get a 2 and a 3 to work out. But what you could do is, you could double every number. I'm just going to write odd even. And doing that, that becomes a 2. That becomes a 2. So again, now I have 2 cobalts, cool. I got 6 fluorines. How can I get that 2 to be a 6? Exactly. And that's cool. Oh, I got 6 chlorines. Dang. Not too bad. Not too bad at all. And then this last one, kind of same process. I'm going to put a 1 here. That looks to be the biggest thing to me. 1 boron, 1 boron. 1 nitrogen, 2. Uh-oh. Well, I got to double everything then. I got 2, I got 2. I've got 1 here now because I'm stable. I got 2. I got 2. I got 2. And I have 2. Here, though, I have 6 fluorines. We're going to have another 3F2. Again, that's going to be these reactions. Again, they kind of all work here. I like these examples. I think they're pretty solid in what they do. I'm just going to pan out really quickly because, again, I'm close to that 15 minutes. So if you zoom out just a bit. So those are all the answers. And what I am going to do is I am going to erase this top one really quick, okay? I'm going to put the very last one I do. The video should be around 16 minutes and we'll be good to go. Again, I did clean my board over the week, but I have tried some different things with the light. So again, please, all feedback is appreciated. Again, it looks different on YouTube than it does with me here. Again, that's a really good thing. It's a really bad thing. I'm just going to try to clean this now. And let's try this really quick. You know what? Let's do C15 H30 plus oxygen yields CO2 and H2O. It is a combustion reaction. Now, looking at that one, again, it's pretty big. Sorry for the jerkiness of the camera there. Very big numbers on the carbon. 15 15. Oh, well, I got 30 of these. I need a 15 here too. And what you'll notice here is when you're looking at oxygens, and again, I got the 15 from here and here. I got the 30 and 30. However, if we're looking at this, we have 30 oxygens and we have 15 oxygens for a total of 45. And because there's only 2 oxygens here, there's no way mathematically you can get a 2 and a 45 to play nice. You can't put 22 and a half here. You just can't. So this is an odd even rule. Again, this is where you're normally going to see it. So it is worth doing one really quick. So simply what we do is we double everything. We just double everything, which means now we're at a 2. Now we're at a 30. And now we are at a 30. This will double all the oxygens. 45 times 2 is 90. And as big as that is, can we get 90 from 2? Absolutely. Because 90 divided by 2 is 45. So that one's big. Those numbers get really big. But honestly, like, at least the math plays nice that time. There are harder ones to do than that. So again, that's just a little review on naming really quickly. It is worth noting, again, I'm just going to back it up really quick. So everyone can see a little bit. Again, I apologize, I have the camera pretty stuck. Again, a few things to notice with balancing that are kind of important. Please just make sure that you just keep in mind it's not really too bad. It's not a scary thing. You just got to put a 1 and go from there. This week there will be a quiz on Tuesday right now. Balancing's part of it, word problems are part of it, but we'll talk more about on Monday. Again, thanks to all the tater tots for watching this video. Again, shout out to Carolina for coming up with tater tots. I'll figure something out with that. But definitely shout out to her, because that was definitely her idea. Again, I'll see you later. Peace, road bro. Peace. Shout out 6 Hour.